Hi guys, welcome to my YouTube channel. Today we are continuing with our series. We are going to revise section C of Combined Science paper 2 that was written in November 2023. In the final exam, candidates are required to answer N2 questions on the separate answer sheet provided. But here we are going to answer all the questions since we are doing our revision. So the first question, it is reading table 10.1 shows characteristic of three elements A, B, and C. The letters are not the real symbols of the elements. So we are supposed to complete table 10.1 by writing proton number of elements A and the electronic configuration of element B. So here we need to write the proton number of element A. We are going to be guided by this information. This electronic configuration is 281. It is guiding us that that element is positioned in group 1 of the periodic table because it is 1 is the valence electron. So it means that it is in group 1. And also it is the mass number of 23. So what we need to do is we need to go and check on our periodic table the element that is in group 1 and also that is in mass number of 23. So the periodic table is not that clear, but I can say that the element with mass number of 23 is sodium, and also sodium is in group 1 of the periodic table. So it is going to qualify to be our element, which is element A. Also the element A is the mass number of 23 and the proton number is 11. So we are going to write 11. And then next we want to find the electronic configuration of element B. We are going to be guided that this element is proton number of 18 and also mass number of 40. So we can check this information on our periodic table. So even without checking on the periodic table, we can write the electronic configuration. If the element has 18 protons, it also means that it has 18 electrons. So it means in the first shell, we are having 2 electrons, and then in the next we are having 8. And then we say 18 minus this, 2 plus 8, we get 8. So it means that the electronic configuration is going to be 2, 8, 8. So if we check on our periodic table, the element that has a mass number of 40 is argon, and also a proton number of 18 is argon. So this is the electronic configuration of argon. And then on part 2, we are supposed to state the group to which element A belongs. It belongs to group 1. Why? Because it is this one is valence electron. So we are going to put it in group 1. And then on part 3, we are supposed to identify using A, B, or C the element that is a noble gas. So 18 is noble gas. B is noble gas because it is an electronic configuration of 288. The one that is in the valence electron is 8. So it means that it is a noble gas. And then on B part 1, we are supposed to draw a dot and cross diagram to show the bonding between elements A and C. So element A, it is sodium, and element C is oxygen. When we combine sodium and oxygen, we are going to form sodium oxide. So what happens is that sodium is in group 1. It is going to lose 1 electron to form octet configuration. And then oxygen is in group 6 of the periodic table. It requires 2 electrons to form octet configuration. So this is how we are going to write our dot and cross diagram. The formula for sodium oxide is Na2O. It means that one oxygen requires 2 sodium that are going to donate electrons for it to gain octet configuration. So in our dot and cross diagram, we are supposed to show that we need 2 sodium ions and 1 oxygen ion for us to have sodium oxide ion. So this is a dot and cross diagram of sodium oxide. We are indicating that we need 2 sodium ions. 2 sodium elements, they are going to donate 2 electrons, so that we have 2 Na 1 plus, and 1 oxygen requires 2 electrons for it to become stable. So these are the 2 electrons that have been donated by 2 sodium ions. So this is the dot and cross diagram of sodium oxide. Let us move on to the next question. And then on B part 2, we are supposed to state N1 physical property of the compound formed between elements A and C. So here we are going to have ionic compound. We are supposed to state the properties of ionic compounds. Ionic compounds, they have high boiling points, high melting points, they conduct electricity in molten state, and they are crystalline solids and are brittle in nature. And then lastly, on part C, we are supposed to calculate the number of moles in 69 grams of element A. So the formula of calculating the number of moles is given mass over molecular mass. So here, the molecular mass of element A is 23, and then the given mass is 69 grams. So we are going to say 69 divided by 23 in order to get 3 moles. So this was the complete solution for number 10, that was in November 2023. On number 10A part 1, we're supposed to complete the table by writing proton number of element A and electronic configuration of element B, which we have managed to do. And then on part 2, we're supposed to state the group to which element A belongs. It belongs to group 1 because the valence electron is 1. And then on part 3, we're supposed to identify using A, B, or C the element that is a noble gas. Element B is noble gas because the noble gas have valence number of 8 electrons. And then on B part 1, we're supposed to draw a dot and cross to show the bonding between elements A and C. Element A is a metal, while this element C is non-metal. So if we combine a metal and non-metal, we are going to form ionic bond. And in ionic bond, there is going to be electron transfer. Electrons are going to be transferred from sodium to oxygen. Oxygen is in group 6 of the periodic table. It requires 2 electrons for it to gain octet configuration. So we are going to have 2 sodium ions donating 2 electrons to oxygen in order to get sodium oxide. And then on B part 2, we're supposed to state N1 physical property of the compound formed between elements A and C. Elements A and C, they are going to form ionic bonds, and ionic compounds have high melting and high boiling points. They conduct electricity in molten state. They are crystalline solids and brittle in nature. And finally, the last question was requiring candidates to find the number of moles. Number of moles is equals to given mass over molecular mass. Molecular mass of sodium is 23. So we say 69 divided by 23 in order to get 3 moles. Let us now move on to number 11. Number 11, sulfuric acid is manufactured by the contact process. Name the two raw materials that are used in the production of sulfur trioxide. So in order to have sulfur trioxide, we need to combine sulfur dioxide and oxygen. So that those are going to be the raw materials that are needed. And then on part B, we are supposed to give N2 conditions needed for the production of sulfur trioxide. We need vanadium pentoxide. We need a temperature of 400 to 450 degrees Celsius and a pressure of 1 to 2 atmospheres. And then on part C, we are supposed to describe how each condition stated in B affects the production of sulfur trioxide. So first I'm going to explain vanadium pentoxide. It acts as a catalyst that is going to increase the rate of reaction. And then 450 is a compromised temperature, producing a fairly high proportion of sulfur trioxide in the equilibrium mixture in a very short time. And then low pressure of 1 to 2 atmosphere is used as there is no need for high pressure, and it is enough to push reacting gases through the reactor. And then on part D, we are supposed to describe the dilution stage in the contact process. So what happens is that we can't dilute sulfur trioxide direct because a mist is going to be formed. But what we need to do is we first need to react sulfur trioxide with concentrated sulfuric acid to get what is known as oleum. And then the oleum is then diluted in order to obtain concentrated sulfuric acid. So I'm going to write how the process occurs. Finally, on E, we are supposed to calculate relative molecular mass of sulfuric acid. So when we are calculating molecular mass of sulfuric acid, we are having 2 hydrogens. So we write 2 times the atomic mass of hydrogen is 1. And then we are having this sulfur. Sulfur is atomic mass of 32. And then we are having 4 oxygen. So we are going to say 4 times 16. So here it is 2 plus 32, we get 34. 34 plus 64, we get 98. So our answer is going to be 98. And you should take note that relative molecular mass doesn't have units. So we are just going to leave our answer as 98. So this was the complete solution for number 11 that was in November 2023. We're supposed to name N2 raw materials that are used in the production of sulfur trioxide. We have sulfur dioxide and oxygen. And 2 conditions that are needed for the production of sulfur trioxide. We have vanadium pentoxide, temperature of 400 to 450 degrees Celsius, and a pressure of 1 to 2 atmospheres. And then on part C, we are supposed to describe how each condition stated in B affects the production of sulfur trioxide. Vanadium pentoxide acts as catalysts that increase the rate of reaction. And then 450 degrees Celsius is a compromised temperature that produces a fairly high proportion of sulfur trioxide in the equilibrium mixture, but in a very short period of time. And then the low pressure of 1 to 2 atmospheres is used as there is no need for high pressure. That 1 to 2 atmosphere is enough to push reacting gases through the reactor. And then on part D, we're supposed to describe the dilution stage in the contact process. So dilution of sulfur trioxide in water can yield sulfuric acid. This is, however, dangerous and is not followed. The addition of sulfur trioxide to water is highly exothermic and causes the fuming of sulfuric acids. And the fumes, they prevent the further dissolution of sulfur trioxide in water. So accepted method is to dilute sulfur trioxide in concentrated sulfuric acid in order to produce oleum, and then that oleum is going to be reacted with water in order to produce concentrated sulfuric acid. And then the final question on number 11 was to calculate relative molecular mass of sulfuric acid. So we need to add the atomic masses of all the elements that are present in that compound. So we have the 2 hydrogens, 1 sulfur, and 4 oxygen. So we are going to say 2 times 1 plus 32 plus 4 times 16 in order to get 98. And relative molecular mass doesn't have units. That was all about number 11. Let us move on to the final question of section C. So number 12 is reading. Fig 12.1 shows an experiment between iron 3 oxide and coke. We are supposed to explain the term oxidation. So there are so many ways of defining oxidation. Oxidation can be defined as loss of electrons, or a gain of oxygen, or an increase in oxidation state of ion or atom, or a loss of hydrogen. Oxidation is loss of electrons, gain of oxygen, increase in oxidation state, loss of hydrogen, all are considered as definitions of oxidation. And then on part B, we are supposed to write a balanced chemical equation for the reaction between iron 3 oxide and coke. So here we are having Fe2O3, and then we are adding coke, which is carbon. You should know that if you add iron 3 oxide and carbon, you are going to form iron and carbon monoxide. So we are going to write iron and carbon monoxide. And then we need to balance our equation. Here we are having 2 ions, so we need to put a 2 here for our ion to be balanced. And then we have 3 oxygen, and here we have 1 oxygen. So we need to put our 3 here, so that we have 3 oxygen, 3 oxygen. And here we have 1 carbon, 3 carbon, which implies that we need to put a 3 here. So this is a balanced equation for the reaction between iron 3 oxide and coke in order to produce iron and carbon monoxide. So the iron oxide is going to be in solid state, whilst coke is in solid state, and then iron that is going to be formed is in solid state again, and carbon monoxide is gas. So you need to mention all this in order to get your 3 marks. And then on part C, you're supposed to identify the oxidizing agent in this reaction. When you are saying an oxidizing agent, it is a substance with the ability to oxidize other substance. So we can see that iron 3 oxide is the oxidizing agent because it is going to donate this oxygen to carbon, so that carbon is no longer carbon, it is going to be carbon monoxide. So it is described as an oxidizing agent because it is causing a certain substance to be oxidized. And then on D part 1, we are supposed to name N2 elements which are added to the solid product to make stainless steel. So we are going to use chromium and nickel. And then on part 2, we are supposed to state N2 properties of stainless steel. The properties of stainless steel are corrosion resistance, high tensile strength, very durable, temperature resistance, attractive appearance, and recyclable. And then finally, we are supposed to give N2 uses of stainless steel. Stainless steel is used in production of cookware, kitchen utensils, and cutlery because of its hard wearing, corrosion resistance, and it doesn't affect the flavor of the food. And then it is used in the construction, automotive industry, medical and pharmaceutical industries. This was the complete solution for the number 12 that was in November 2023. First, we are supposed to explain the term oxidation. Oxidation can be defined in terms of electron transfer. It is going to be defined as the loss of electrons, or it is going to be defined as the gain of oxygen, or the increase in oxidation state, and the loss of hydrogen. And then on part B, we're supposed to write a balanced chemical equation for the reaction between iron 3 oxide and coke. So iron 3 oxide and coke produce iron and carbon monoxide. And then on part C, we're supposed to identify the oxidizing agent in the reaction. Iron 3 oxide is going to be the oxidizing agent. When we are saying oxidizing agent, is the one that causes other elements to become oxidized. So iron 3 oxide is going to donate oxygen to carbon for us to have carbon monoxide. And then on part D, we're supposed to name 2 elements which are added to the solid product to make stainless steel. We use chromium and nickel. And then the properties of stainless steel are corrosion resistance, high tensile strength, very durable, temperature resistance, and attractive appearance. And then on part 3, 2 uses of stainless steel are cookware, kitchen utensils, and cutlery production. They are used because of their hard wearing, corrosion resistance, and also it doesn't affect the flavor of food. It is used in the construction, automotive industries, medical and pharmaceutical industry. This marks the end of our tutorial today on section C that was written in November 2023, Combined Science Paper 2. Thank you so much, guys, for following me on this channel. Please don't forget to subscribe, like, and share my videos. I love you all. This is Eve signing out.